Okay, so I'm gonna walk you guys through these notes. Obviously this class is shorter than last week's. Last week's we had 75 minutes. Now we're back to normal, whatever's normal, 60 minutes. And on the homework, some of you guys had a little bit of trouble with this kind of question where you had to figure out which function to start with and the order to go in. How'd you go? Yeah, if you could, don't. So homework, I'm gonna give you guys a grace period. So if you don't have it due on time this week, don't worry. I'll still give you like full credit. Starting next week, we'll start being a little more formal with that. Yeah, because you guys are just getting back, and of course you guys can't get your phones out. So next week we'll be a little more formal with the homework. So okay. Yeah, you just got to upload it, right? Yeah, because that's how I give you guys credit for it. So you have to upload it. So, and plus I want to see your work, right? Okay, so let's look at this problem here. Actually, we'll just go around and have someone read to us. So, Aiden, can you read the instructions? And John, you can read next. Don't worry. So you can read the part that says function machines, the paragraph. Actually, you should have notes in front of you. You don't have to read. It's in the notes packet I handed out last week. It's in the notes packet. Do you have it? There we go. Perfect. Yeah. It should be on 1.2. There we go. Yeah, if you read the part that says function machines, the paragraph that follows.
Your teacher will give you a set of 4 function machines.
Hey guys, quiet please. Thank you.
Teacher will give you a set of 4 function machines. Your team's job is to get a specific output by putting those machines in a particular order so that one machine's output becomes the next machine's input. As you work, discuss what you know about the kind of output each function produces to help you arrange the machines in an appropriate order. 4 functions are reprinted below.
Okay, so I'll do part A to kind of get you guys started. And then I'll have you guys do part B in your groups. So you have 4 functions, right? You have root x, negative x minus 2 squared, 2 to the x minus 7, and negative x over 2 minus 1. And just so we are familiar with what each type of function is, this is a square root function. I mean, I think it's pretty obvious. What kind of function is called g of x? What name does that get with the square symbol?
Exponent function?
Actually, that's going to be h of x. That's exponential. Because x is in the exponent, right? But x is not the x is the base in g of x. The exponent's a 2. We have something squared. Well, first of all, what kind of shape do you expect for the graph? We have something x squared. So, okay, probably good. There's also a more formal name for it. It starts with a Q.
Quadratic.
There you go. Perfect. It's quadratic, yes. It's all right. You guys are a little rusty. It's all good. So that's a quadratic, and let me write that better because that's kind of sloppy. And of course, k of x, what do we call that? If you just have plain old x with a number. Linear, good, perfect, good. Now, as you expect, exponential, the output will be really big, right? Square root will be kind of small, linear kind of small, quadratic kind of in the middle. So for part A, they're asking to start with 6. And after you've gone through all 4 functions, you want the final answer to be 11. So just, and you don't have to write this down. You guys can just pay attention for now. Let's say I put the functions like this, right? So I start with F, go G, H, K. So I started going alphabetical order. So F, G, H, K. Just to see what happens. Okay. If I put the 6 inside, right? What gets spit out if I put 6 inside of F? Into F. If I put 6 inside this function, what's gonna be my output? Yeah, which is kind of a weird number, right? Like, what is root 6? Like 2 point something, it's kind of weird. Now, this will get put into G. Okay, I definitely made this complicated, but it's okay. Complicated's fine. If I put root 6, so here's what's happening. You put a number in, you get an output. That output now becomes the new inputs for the next function. So root 6, which is really nasty, but I put in the next one. If I put root 6 into that one, what's going to happen if I put root 6 in that one? What do I have to do to compute that? I have to do root 6 minus 2. Just kind of tough to do in your head, right? I have to square that and put a negative afterwards. So what I'll do, let me pull up a calculator right now. Let's see. This one should work. Math department. Perfect. There we go. I'd rather use this one than the one that's built into the computer because that's kind of weak. So yeah, so I got to do root 6 minus 2. I gotta square it and then multiply it by -1. Oh boy. That is nasty. So going back to the notes, that's going to be negative 0.202. Yikes. Okay, now I'm going to throw into the h function. Okay, good luck with that. I got to do 2 raised to that power. That's really hard to do in your head. I'll do it down here. I got 2. So you guys don't have to write this down because I'm doing this in the wrong order on purpose. So if I do that, just want to show you the process, right? I have to do 2 raised to that number. Sorry, let me repeat that. 2 raised to negative. Just try it one more time. 2 raised to negative. Let me grab it now. Is that right? Yep. Hold on. Minus 7. Yeah, I get negative 5.85. So I know this is not going to work. And then I got to throw into the 8. Yeah, we'll say 5. Then I got to throw into the k function, which is divide that by 2, multiply by -1, and subtract 1. Clearly, I don't get what we want. We're supposed to get 11 as a final answer. I don't get that at all. I get 1.92. Okay, so here's when we have this activity. If you're starting with 6, using f first was a bad choice. Why was f a bad choice for my first function? Starting with 6. What else? And root 6 is not perfect. That's not a perfect square. So that was a bad choice. Probably I may start with like G or K, perhaps. You can start with H. I think H would be a bad choice too, though, because that'd be a pretty big number. So I'm not sure if that's really the right choice either. Maybe it could be, I don't know. So what I want you guys to do is figure out the right order. Where should you start with 6? And figure out the right order. So maybe you start with K, but then you have some choices to make after that. Then which one you throw into after that, right? So clearly F, G, H, K was the wrong order. That was terrible. Not a good choice. So I'll give you guys a moment to do that. I'm going to do it till I'll freeze my screen. See what order you guys come up with. When someone has it, let me know or let us know, and then we'll share. All right. So go and try to figure it out. It's kind of a fun puzzle. All right. Feel free to chat away. So I know you guys love to chat. All right. Let me freeze the screen. I'll do it. Yeah, sure. Go on.
You gotta factor in you have to factor in negative sign there. So it's just negative 6 up to. So negative 16. You just said it was way higher. I said 16. Right, so you want to start with 16 or negative 4?
All right.
-2, not -9. No, we gotta So we start with No, no, that's the thing. So that's 4 negative 6 over 2. Then
Maybe something here, I don't know what the plugins are.
Then
And maybe
you-
support them.
Are we free to do it?
Yes.
Yeah, well, there's only low. Oh, yeah, you want to hold them at the end. What math are you guys doing in other sections? Are you guys doing something similar math or something different? Different, okay. Oh, you just said last year, okay. Yeah. Yeah, it's ball count up.
Oh, it's in English.
What is it? No, I know why you want. I know why you want to put it. You see, there's a difference. So this is-
Okay.
So. I think even though it's very simple, it's very different. So we're doing. You want to split that first. You guys, do a hit. Start with G. Start with G. G is the way to go. Start G. G is the way to go. Start G.
No, because we ended with 1 here.
What do you get? GKHF? Excellent, got it. Good work. Good. Okay, start with G. Hopefully the next one will be obvious after that.
We gotta start with
I hit second and then X squared. X squared is down below. Right there.
Oh, great. Or square. I think it's that one. Oh, excellent. Oh, you want do two to the second. Yeah, you're on the right track. Yeah, you're gonna get it. You got it? 7? You got it. Okay, let us got it. I think you're on the right track. Oh, wait. Okay, schedule work. No. All right, let's go over, guys. Here we go. All right, guys, quiet. You guys do part B in a moment. Guys, please. Oh, sorry. Well, no, I'm slight part A. I'm slight, not that you're right. Yes, K is next. Okay. No, I just unfroze the screen. No, okay, guys, settle down. All right, so GKHF. So the problem with K is if you plug in 6, you get -4. I'm not sure what to do with that because I'm not going to do 2 to the -4. Product between 1 over 16. I can't square it negative. It's imaginary. If I plug in -4 into here and they have -36, which is really large. So starting G seemed to make most sense. That I get -16. And remember that negative comes afterwards. John, go back to this.
Just get it.
All right. And if you put -16 to this one, you should get 7. But 7 makes sense over here. You would get 128 minus 7 is 121, and root 121 is what? So it goes GKHF. Now, go and do part B, doing the same thing. You're going to start with 64. For part B, start with 64. End with a large number. My guess is H is going to be last if you want a big number at the end. So start with 64. Hopefully it's obvious which one to start with. For part B, H should be last. No, for part A, F was last. But for part B, most likely H will be last. I don't know. We'll see. I could be wrong. Maybe
I could be wrong though. So,
I ain't there yet.
all right, let's do part B, guys.
You can find the order again.
Yeah.
I can go on this.
Yes. All right, I'm gonna do it too, guys.
Alright, bro, how we doing? So each is last. This one each. Alright, we got 64 in and we got a hit.
The same thing.
Yeah. This one, yeah, but then we keep it. Each is loud. Second. We're doing B.
I know, I'm just saying, there's 131 and 65.
Same. 131.
Oh, 65.
Yeah. Input 64.
Okay.
Bless you.
Thank you.
Welcome. All right.
A is double. Bro, you already do that, right?
All right, here we go. Hold on. Okay. There we go. Let's close the screen. All right. Should be what you guys got? Yep. Yep. Okay, here we go. All right. So you should get F, G, K, H. So 64 makes sense to do with that because it's a perfect square. Because you gotta have some perfect square, right? And then I wouldn't do H necessarily, because I might want to say at the end, maybe a big number at the end. So either G or K is what I'm gonna go with. If I go with G, I get negative 36, and K, I get 17. 2 to 17 power is a really big number, but it works out. If you did G, you did F, K, G, H, that would have been kind of weird, I think, because you had a negative. And it just would make it worse, and then you're plugging it. You don't want to plug a negative exponent here, right? You want that to be a positive exponent. So doing G then K help us get that. Because you're doing a negative of a negative. So anyway, the whole purpose of exercise, understand functions as well as just think good mental math, or not mental math, but just think critically. I guess that's probably a better way of putting it. Okay, some notes here at the end, guys, and then these notes are very short, so you guys should have plenty of opportunity to do homework, get it all done, and have no homework again. That's nice, right?
That is nice.
All right. So function notation, guys, quiet please. Thank you. All right, that's function notation. So give you a good example. Here we go. Here's the reason why we have function notation in the first place. Let's say I told you this. If f of x equals x squared plus 1, find f of 2. Of course, what do? You plug 2 in for x and work it out, right? So hopefully that seems really straightforward. Jasmine, oh yeah, go ahead. Yeah, yeah, good. Oh, you want to turn out? Was it too cold? Or you want to turn it down? Oh, the lights. Oh, so I put them in the fans. It's gonna get too cold with the fans. Oh, yeah, totally. Turn on the lights. It's all good. Is that better? Good. Okay, great. So anyway, that's function notation. If f of x equals x squared plus 1, find f of 2. all it means is plug 2 in for x and work it out. We actually had them last homework. Now, why do we have functionation in the first place? What if I wrote the question like this? If y equals x squared plus 1, find what y equals, can't spell, when x equals 2. Now, personally, I think it's much easier if you think about it. All these words here, let me highlight it. All these words can we express more compactly like that? Would you want to write 1, 2, 3, 4, 5, 6, 7, or just something very short like this? This is much easier. So this is, I know it's kind of cryptic when you see functionation. We have it. I jokingly say that mathematicians are lazy because we want to get to the point pretty quickly. And there you go. F of 2, that's all it means. All this just means F of 2. That's all it means. So you could think of f of x as y if you want. I usually do.
Yeah.
You can. In fact, you can replace f of x with y if you want. I don't care. But you have to understand what f of 2 means. It just means plugging 2 for x. So it's very, very simple. That's why we have it. And then for composite functions, which that's something that's going to be a big deal in pre-calculus and calculus much later on. But composite, when you plug a function into another function, plug a function into another function. So it's kind of like the function machines we just did. Charlotte, go ahead.
So the first thing you have written there for the thing above it. The phone part.
Oh, hold on. Let me go back. No, no worries.
No, sorry, I'm just looking at the first sentence that you have.
Just right here.
That sentence on there, is that part of the composition or the function notation?
Function notation.
Oh,
Yeah, I just ran out of space.
okay.
Yeah, well, all I was doing is I was rewriting what's in red in more layman's terms. That's all. Yeah.
No worries. This is why I have this on Zoom. So I can do this. So you plug a function to another function. So it looks like this. So that's called function composition. We'll talk more about that when we have some examples, but that's just an example. So we kind of did that already when we did like all the different functions like f, g, h, k, whatever. So, and composite means you're just, composing new functions. You're just throwing new things into something else. So, all right, let's look at this example here and one more example, then you guys can do homework. All right. So, John, actually, do you want to read 118, please? 118.
Yeah.
All right, guys, give John your attention, please.
Time. It may seem like a silly question, but to sketch a graph that represents the relationship you first need to decide which axis will represent which one.
Okay, so I mean, we know that it's the first one, right? I mean, we know that, but let's look at part A. So part A, when you graph an equation such as y equals 3x minus 5, which variable depends on the other? So y depends on x, right? We know this. Y depends on x. Which was not dependent, x.
Independent.
Independent, exactly. And that's because we get to choose whatever we want for x. It's our choice. We do whatever we want for x. That's all. Part B. Now, which one's dependent? It's going to be the time of day. Sorry, temperature, my bad. And the time of day is independent. So say, for example, you're figuring out what to wear because if it's going to be hot or cold or whatever. So if it's early in the morning, maybe you dress in layers, right? Or if it's late at night or you're camping outside, have a sleeping bag or several blankets, right? But if it's the middle of the day or like 4 o'clock, it's really hot, maybe you wear shorts or a tank top or whatever, right? So the temperature depends on the time of day. So you could choose like what time of day maybe you want to go out and do something, but the temperature depends on that. And so sketch a graph that shows the relationship between temperature outside and time of day. Actually, let's do this. Let's go to AccuWeather. Let's go to Atherton. Let's go to hourly. All right, so we see that right now it's probably hitting a peak, right? It's 86 degrees, we're getting close to 86, hit 87, 86, 84, 82, 79, 76, 73, it gets cooler, right? And if I do the next 12 hours after that, midnight 66, 64, cools down to 60. California's lovely, right? You don't get really great weather here. Then it starts picking up again in the morning, right? So what I'll probably do is I'll do a quick sketch. See here. Hold on, I'm in the wrong place. Yeah, let's do a quick sketch here. So let's say time is here and temperature is at. Because again, I could choose what time I want to look at. Like what's the temperature gonna be like at 8 o'clock tomorrow morning, right? I get to choose that. The temperature depends on that. And what was the lowest temperature roughly for right at this time of year here in Atherton? Like about 60. Highest probably about we'll say 90. I mean, I don't think it's gonna hit 90, but let's say it does. Around, and so let's say this is 12 a.m. Let's say this is 12 p.m. And this is the next day. So we're doing a 24-hour, right? In 24 hours. So what was the temperature around 12 a.m.? Probably pretty close to 60, not exactly. And it kind of got cooler, right? And then start heating up, right? Then it starts cooling down a little bit as we get close to the evening. So my guess is that it probably looks something kind of like this, right? It's kind of wavy. It's definitely not straight, that's for sure, right? But but of course, maybe it might get really hot the next day. Maybe it'll just all of a sudden do that. Who knows? Or maybe it just gets cooler. Maybe get like a bunch of like marine layers. Who knows? So anyway, that's just context, right? Not 100% accurate, but it's good enough. All right, last one. Some more. Can you read 119, please?
For the function of x value, that are the length of pieces to x off and y values that are the length of the pieces left over. Which representation best portrays the situation y?
All right, thank you. So let's say x is the the length of the piece she cuts off, right? And y is what's left over. Okay, got it. How would I make an equation for that? What do you guys think? So what's left over depends on how much you cut off. You get to choose how much you want to cut off, right? What if you want to cut off 2 feet? Then how much is left over? 28, of course. What if you want to cut off 10 feet? How much is left over? So what equation do you think you could make? Go to Elise, go ahead. Perfect. 30 minus x. Love it. So just being hypothetical, like if you made a table, actually, that's what we probably should have done. Like if you cut off nothing, you have 30. If you cut off 1, you have 29. Cut off 2, you have 28. Cut off 10, you have 30. Sorry, 20. If you cut off 15, you have 15. And so forth. Or cut off 20, you have 10. So hopefully 30 minus x makes sense because you're taking away from 30. So I have an equation, check. I have a table, check. And let's do a graph. Graph's probably the best way to look at it. I mean, if you look at the equation, what's my y-intercept? If I plug in 0, what do I get? 30. And what's the slope here? It's what's the slope? -1. So you go down 1, right 1. So I plug in 1, I get 29. And it's going to cross. I know it didn't just scale, but it's okay. But ultimately, if I cut off 30 feet, well, then you have nothing left, right? So that's what happens. Which representation best portrays the situation? It's kind of up to you. I don't know. It's really whatever you prefer, I would say. I think a table's pretty good. That kind of helps to see how much is left over. A graph could work too. The equation might be kind of confusing because you don't know the context behind it, right? So anyway, that's just like some word problems. Questions on that one? No? All right. You guys should have plenty of time to knock homework out. So it's good. We did an activity. You guys learn more about functions. Some more good. What's left over?
How much wood is left over?
Stop it.
Yeah, sorry, I should have said that. X is what you cut off.
Yeah.
So if you go like to Home Depot, like you get a big piece of wood, you say you cut off 2 feet, that's X. And what's left over is 1.
Yeah, so Y is what's left over. X is what you cut off. All right, the homework you guys should have a shortcut, yeah. Oh, yeah, I'll come and I'll ask you about that later. Okay, homework's right here. It's just these problems. You guys should have the packet, which is right here. No, that's 1. That's 1. Hold on. So take advantage of time to get homework done. Yeah, so you got more of the same. I'll make the answer key for you guys. So you guys have it. Okay, and that's all. That's all we're doing today. All right. Easy class.